AB Calculus Note Card 27, Derivatives of Inverse Trigonometry, Logarithmic and Exponential Functions. This is the 28th lesson in the note card series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. This topic is kind of an oddball topic in that you have the inverse trig functions, and you have this ddx of arc sine, which sometimes you'll see written as the sine -1 of u instead, and then cosine -1 u, possibly arctangent would be tangent -1, and that's all inverse notation. And fortunately, is this topic taught or tested very much on the AP test? No, not very much. Maybe every other time you'll get a problem like this. And this is one with not a lot of extension beyond where we are here, pure memorization. And so my recommendation would be to shortly before the test memorize these first 4 functions here, and I'm going to write them down on a card, and they're not too hard to memorize. As in the other type of trigonometric derivatives, you have, anytime you have a derivative that begins with a c, you're going to have a negative sign. The sine and the cosine are going to have, they're going to be, only difference is one has a negative sign from the other instead in front of the u, and then you have the square root of 1 minus u squared in the denominator for both sine and cosine, or inverse sine and inverse cosine, and for inverse tangent and inverse cotangent you have 1 plus u squared. So these are not very hard to remember. As far as I haven't seen this arc secant ever be tested, nor the arc cosecant, so that would be a surprise. I just recommend memorizing these first 4 circled. As far as the exponential functions below, we're going to go over some problems on those. Fortunately, the next 2 note cards, 28 and 29, are going to cover exponential and natural exponential functions, natural log functions. And so these things at the bottom here, I don't expect to be tested on the AB Calculus AP test this coming May. So let's go on, do some problems here. We have ddx of arc sine x squared. And again, I'm just going to write this down. ddx of arc sine of u is going to be equal to u prime over square root of quantity 1 minus u squared. Okay, and so taking that into account, up here we're going to have u is going to be equal to x squared. So for this we're going to get u prime, which is 2x over square root of quantity 1 minus u squared, which is going to simplify to 2x over 1 square root of quantity 1 minus x to the 4th power. So really that's it. I'm going to drag this thing down here, kind of get it out of the way a little bit if I can. If it'll let me do that. Maybe it won't let me do that. Here it will. There we are. I'm just going to bring this down here. And then for ddx of cotangent, that's going to be in this place down here. I'm just memorizing from my card, so inverse cotangent is going to be equal to negative u prime over 1 plus u squared. So let's go ahead and apply that in this case. We're going to have u is equal to x to the 1/2 power, or square root of x. So u prime is going to be equal to 1/2 x to the negative 1/2 power, which is going to be equal to 1 over 2 square root of x. And so let's go ahead and go about this. So our answer is going to be negative u prime. So we're going to have negative 1 over 2 square root of x. And it's going to be over 1 plus square root of x, that's u squared, which is going to be x. So our answer is going to be negative 1 over 2 square root of x over 1 plus x. So that's going to be our answer for that one. And finally, for arc tan of cosine x, well, in this case, u is going to be equal to cosine x. So let's write this d dx of inverse tangent u is going to be equal to u prime over 1 plus u squared. So let's write that out up here. We have dy dx is going to be equal to, if u is cosine x, u prime is going to be negative sine x. So in the numerator we have negative sine x. And then in the denominator we have 1 plus cosine squared x. And I think that's going to be just it. So let's go to the next set of problems, which is the one that has the derivatives of the exponentials and logarithmic ones. So when we find the derivative, we have like format. Let me just write this down here. I'll write up here. d dx of a, I'll put d dx of a to the power of u is equal to the natural logarithm of a, that's ln a, equals natural logarithm of a to the u, and finally du dx. So that will get us through, I think, problems 4 and 6. So y prime is going to be equal to ln a. So this would be in the place of a would be equal to 2 and u would be equal to 3x. Okay, so y prime is going to be ln of 2 times a to the 3x, a to the u, times du dx. Well, that's going to be times 3. So just kind of simplifying this out in normal fashion, we would write this as 3 ln 2 a to the power of 3x. Okay, now for this one down here, we would have problem 6, we would have a is equal to 5 and u is equal to x cubed plus 5x. And then we can just follow like we did earlier in problem 4. So we would have y prime is going to be equal to ln of our base, which is 5, and we're going to have a to the power of u, so a to the power of x cubed plus 5x, okay, times the derivative of u, which is going to be 3x squared plus 5. Okay, and then simplifying that below, we're going to have y prime is going to be, I don't know if we could write that any more simply, so I think we're just going to leave it in the format we have up here. And this right here is not a, I'm going to put that in the right place so we can see where the power is and so forth. Okay, next, for the logarithmic derivation is going to be very similar, except we say d dx of log base a of u is going to be equal to 1 over natural logarithm of a times 1 over u times du dx. And so for this problem here, we're going to have our base, our a is going to be equal to 10. Our u is going to be equal to cosine x. So now working this out, we're going to have 1 over natural logarithm of a times 1 over u, so that's going to be times 1 over cosine x. Now we could have written that, instead of 1 over cosine x, we could have written that as secant x. And then du dx is going to be the derivative of cosine x, which is going to be times negative sine x. So let's go ahead and just write this out. We're going to have 1 over ln of 5, and then we're going to have times negative sine x over cosine x. And we can simplify that further, can't we? We can call this negative sine x over cosine x is going to be negative tangent x over ln of 5. So that's going to be y prime. Now, for this one here, number 7, we have y equals log base 6. So in this case, a is going to be equal to 6. And then we're going to have u is going to be equal to x to the power of negative 1/2, because that's what 1 over square root of x is. And so we're going to say u is equal to x to the negative 1/2 equals 1 over square root of x. So either way. So let's go ahead and write this out. Y prime, working below, is going to be equal to 1 over ln of 6, and it's going to be times 1 over u, so it's going to be 1 over 1 square root of x. And so let me just write this out. 1, well, then let me put the derivative of, and times the derivative of x to the negative 1/2 is going to be negative 1/2 x to the negative 3/2. Okay. But this 1 over 1 square root of x, 1 square root of x, dividing by a fraction is the same as multiplying by a reciprocal, so that's going to be square root of x. So what we have is y prime is equal to 1 over ln 6 times square root of x, which is this thing here, times we have negative 1 over 2, we have square root of x to the third power. And so we can rewrite this as, in the numerator we have negative square root of x over ln of 6 times 2 square root of x cubed. Again, this last part, starting from 4 on, is probably not going to be tested on the AP test this year, but look ahead, especially to note cards 28 and 29 for what will be tested. And as far as what's going to be on that test, especially pay attention to these problems 1 through 3 and this table. Just know what this table is here. I'm going to write the ddx of cosine, inverse cosine of u, which is going to be negative u prime over quantity 1 minus u squared. So that's about all with this one. Good luck, and thanks for viewing.